when I am in the physical class, if you were in my classroom, then usually what I do is that roughly about 1 hour of lectures, I give you a break time. Then you take a small break where you can go out and wash your face, take a sip of water, and come back to the class, and then we will restart. So that your mind is refreshed and so on, because we know that continuously if you are trying to do something, then your mind starts to wandering around and so on. And I encourage you always that please walk out, go out, walk a little, do some activity, take some water. But I don't know, you guys, as soon as I give you a break, you open your phones and so on, and you don't take a break. But that is up to you. Then if you know me, I say that we'll take roughly a 10-minute break, but for 5 minutes we will take a physical break, and then please come back. And then for a couple of minutes we will take a mental break. We will talk of something which is totally unrelated to the course. So you have taken a physical break, you are refreshed, and we also mentally refresh you, and then we start talking of the science again. So it is usually a joke. So let me tell you a language joke today. Now, many of you are good in English. Some maybe are okay, some have a little bit of difficulty, but you have taken a full year of engineering generally in the foundation before you come here. So tell me, what is the difference between the word complete and the word finished? I have given you a homework. You say, I have finished it. You say, I have completed it. I have given you an exam. You say, sir, I have finished. You say, sir, I have completed. What is the difference? Right? So it is a tricky thing that when do you say, I have completed it? When do you say, I have finished it? So let me try to give you a totally new definition. You see, on a serious note, according to a hadith, you know that you are not complete unless you get married. You think I am very complete, I am very good or bad or whatever, but when you get married, you have a wife or a wife has a husband and you have children, then your real life starts and you are completed. So without that, you don't know what is life. You don't know how many trials are there, how many tests are there, what are the, right? So that was the serious part. But in seriousness also, you are not complete unless you get married. Now the definition. If you marry the right person, you are complete. If you marry the wrong person, yes, you are finished. Right? So now you know the difference. If you marry the right person, you are complete. If you marry the wrong person, you are finished. So this is a new definition. Now you understand it. But let me go one step further. If the right one catches you with the wrong one, then you are completely finished. Okay. So this was your mental break. Now back to the slide. We have done two basic types of materials, metals and polymers. Now here is the third type of basic materials category. The third type of basic materials category, ceramics. So again, don't read further. Can you tell me from your general knowledge or from your previous courses, what is a ceramic? Just like what is a metal, what is a polymer? What is a ceramic? Yes, one of you has given a beautiful answer. A ceramic is not a metal, it is not a polymer. Very correct. Yes, very correct. A ceramic is not a metal and it is not a polymer. Okay, so going further, what is a ceramic? You know it, but let us revise directly from here. Let us go to the first sentence. It is inorganic in nature and it has a metal and a non-metal chemically bonded together, right? So let me go back now. Metals are single elements: iron, aluminum, titanium, single materials. Even if you mix something else to it, it is not a compound. When you mix carbon to it and it becomes a steel, it is not chemically new thing. Chemically it is still iron. It is just a mixture. But polymers were long chain molecules. So they were molecules, right? Hydrocarbons, carbon, hydrogen, some other metals. So they were already compounds. So one basic difference is that metals or metal alloys are single elements. They are not chemically compounded, but polymers are chemically compounded. So here ceramics are also compounds. Ceramics are also compounds, but they are compounds of what? A metal and a non-metal. Just 2-3 slides ago, when we were defining metals, we told you that one property of metals is that they can form chemical compounds with non-metals to form new materials. We gave you example of a silicon carbide. Silicon is a metal, carbon is a non-metal. Silicon carbide is a compound which is a new material. Aluminum oxide, aluminum is a metal, oxygen is a non-metal. Aluminum oxide is a new material. These are already examples of ceramics, right? Silicon carbide and aluminum oxide are ceramics. Why? Because they are chemical compounds between metals and non-metals. Now, if these ceramics are there, then they can be crystalline, non-crystalline, or a mixture of both. But mostly 60, 70, 80% times ceramics have crystal structure. So they have this in common with metals. Their greatest things is that their hardness and strength is very high, even higher than metals and many metal alloys. So they are very valuable materials, very high hardness and very high strength. Also, their resistance to temperature is much higher than metals, and their resistance to wear is much higher. What is wear? Do you know? W-E-A-R. What is wear? You see, if there are two parts which are sliding against each other, like the piston and cylinder inside a car engine. There is a piston and there is a cylinder. So the piston is rubbing against the cylinder all the time, going up and down, up and down. So if this happens for a long time, then the surface of both piston and cylinder gets into bad shape. Their surface finish goes down, surface roughness increases. So this increase in surface roughness is called wear. So ceramics are materials which can withstand high temperatures and which have good wear resistance. But the bad thing is that ceramics are brittle in nature. Another very good thing is that ceramics are bad conductors of heat, so they are good insulators because they have high temperature resistance, therefore they are very good as insulators. So if you now write good things, bad things, they are very hard, they are very strong, they have good resistance to temperature, they have good resistance to wear. Bad thing is they are brittle. Because of high temperature resistance, they are very good insulators. So this means one very special application: furnaces. Whenever we make furnaces, why are furnaces made? To melt other metals and other materials, right? You take iron. If you have to make things from iron, you have to melt it. How do I melt iron inside a furnace made of iron? That furnace will also melt. So what you do, you make the furnace with iron, but then inside where you will heat it, you line it with a ceramic, right, and so on. So now it will not melt, right? So lined for heat treatment and melting of metals. Of course, ceramics are used in a space shuttle also for very high temperature resistance, because when a space shuttle goes out of the Earth's atmosphere, it is okay. But when it is coming back, then it is supremely heated because it is traveling with a very high speed, and as it comes down, the Earth's atmosphere is denser and denser, more dense, so the heat increases, right? So therefore ceramics are very good as insulators, and therefore they are used in furnaces, and they are used for those parts of rockets which will come back to Earth, and those parts of the space shuttles which will come back to Earth. So there will be ceramic tiles, right? Similarly, we were talking of very high speed public transport in the future in aircraft. So if they are traveling at 3 times, 4 times, 5 times the speed of sound, then the heat generated will be very high. Therefore, on the outer body of those aeroplanes which are very high speed, there will be ceramic tiles. What are the drawbacks or limitations? This thing, they are brittle. What do you understand by brittle? Right, we will be talking of material properties later. If something is ductile, it is easy to change its shape. If something is brittle, it is very difficult. Right, for example, you have rubber. You apply force, you change it into a different shape. You have metal, you apply a little force, it will not change into shape. But if you apply a lot of force, then you can change it. Yes, you can take it to a rolling plant and change a flat piece of metal into a round shape. So you need more force, but you can still change the shape. But take a piece of glass, a mirror, try to change its shape. You try, when you apply a lot of force, it just shatters into pieces. So it does not change shape, it is brittle. So if something is brittle, then its manufacturing is a big problem. You apply low force or you apply high force. You see, if it is a polymer, it will change shape with low force. If it is a metal, it will change shape with large force. But it will change shape, so you can shape it into different materials. But if it is very brittle, then whether it breaks at low force or breaks at harsh force, it breaks without changing shape. So because ceramics are brittle, therefore the drawback is it is difficult to process. Manufacturing process is a problem. So ceramic products are expensive because of being brittle. Then they have other applications also as abrasives. You know a grinding wheel. You want to sharpen something, there is a knife, it is now dull. So you take a wheel which is called a grinding wheel, you start rotating it and rub your knife against it, and after some time it will be sharp. So that grinding wheel has abrasives, right? So that is made of ceramics. Many construction materials are made of ceramics, like cement blocks and so on. And porcelain, glass, silicon nitride, silicon carbide, these are examples of ceramics. So ceramics have brilliant properties like very high strength, very high hardness, very good temperature resistance, very good wear resistance. But they have a huge problem of being brittle. So manufacturing of ceramics is very tough. We have to have very special manufacturing processes by which we can manufacture ceramics. But if you can manufacture them, then they will have the very good property of high resistance to heat and so on, right? So this is about, these are now some modern ceramics. Normal traditional ceramics are there, but when they are modern ones, they are called engineering ceramics or structural ceramics or advanced ceramics. It is just like there are alloys and there are very advanced alloys called super alloys. So similarly, there are ceramics already, but very advanced ceramics are called engineering or structural or advanced ceramics. And here we are showing you something very, very strange. These are valves and bodies and other things which can be used in automobile engine, right? So these are very modern and very new. Until now, only metals are there in automobile engine components, but these are ceramics. If ceramics can be manufactured into these complex shapes, then they will have very high temperature resistance. So they will be much, much better in life and performance compared to the same components when they are made of metals.